Hey guys, why didn't the quarter run into the street with the nickel? Because it had more sense. Ha ha ha. All right, hope that got you smiling. Now let's have some fun with section 2.2 and 2.4. So let's take a look. It's all about linear relations and writing linear equations. A lot of this will be review from Algebra 1. So let's go through it a little bit together and try some problems together as well. So just recall, a linear graph is going to be a straight line. Okay, relations that have straight line graphs are called linear relations. Their highest power on the variable will be a 1, and there are no products of variables and no variables in the denominator. So if we look at some examples, this first example, let's take a look. Highest power is a 1 on your exponents. There's no product of variables, right? We have 3 times y, but that's just a product of a coefficient and variable. And there's no variables in our denominator. So all of these are examples of linear equations. However, below are examples that are not linear. This first one here has a power of 2, so we do not call that linear. In fact, we call that quadratic. Our second example has a variable in our denominator, so that is not linear. That's going to be a reciprocal or rational function. Our next one has a product of variables, so that is no good as well. And lastly, we have a square root, and what we'll learn later on in the semester is really that's the same thing as having a power of 1/2. So again, we only want a power of 1, so that's not an example of a linear relation. Okay? When we are writing linear equations, we have a variety of different forms that we can write them in. We have slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. This is the most popular form that we use because it's very helpful for graphing. Then we have point-slope form. Point-slope form is y minus y1 equals m times x minus x1. So remember, we substitute in for our slope, which is m, and then we substitute in for x1 and y1, which is an ordered pair. We leave this y and this x alone as the variable. Standard form is ax plus by equals c. Now, there are 3 things that must happen in order to be in standard form. A, b, and c are integers, so no fractions and no decimals. Okay? You have to clear those in order for it to be in standard form. A has to be positive, so that means in front of x must be positive. If it's not, multiply through by a negative. And lastly, the GCF of the 3 coefficients and constant must be 1. So for example, we could not have a 2, 4, and a 6 because we could reduce that. Now, these are 2 that people forget quite often, so I'm going to star them right now. Our equation for a vertical line and a horizontal line. So vertical lines, remember, go up and down, okay? A vertical line is always in the form of x equals a constant. X equals 2, x equals -7. And that's because as I move up and down, the x doesn't change, only the y is changing, right? As I move up, the y gets larger. As I move down, the y gets smaller. But the x remains the same, so x will stay the same. A horizontal line goes side to side, and same deal here. It's going to be y equals k because our y value, as I move left to right, the y value does not change, only the x does. Okay, so even though a vertical line goes up and down, it's in the form of x equals a constant, and horizontal goes left to right, it's y equals a constant. Some other things to recall are x and y intercepts. Those are where we cross the axes, okay? An x-intercept, it always has a y value of 0. So to find an x-intercept, you would plug in, you would plug in 0 for y to find the x-intercept. Okay, and then to find the y-intercept, we would plug in 0 for x. Okay? Parallel lines, recall, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Let's just do an example of an opposite reciprocal. So if I had a slope of 7, then I would have to have a slope of negative 1/7. If I had a slope of negative 2/3, then I'd have to have a slope of positive 3/2. Those are reciprocals. Okay, let's look at some problems and try some together. And then you will fill in the others on your own. So state whether each function is linear or not. So if we look here, okay, remember this is just function notation. Remember that this g of x can always be interchangeable. You could just write that as y equals 2x minus 5. Okay, our function notation is the same thing as a y. So if you ever want to substitute, you can. So if we look here, okay, power is 1, no product of variables, and no fractions. So this is linear. Okay, and I just explained that verbally. What about on B? If we look here, we have a power of 3. So this is not linear, okay, because the highest power is 3. You try C and D on your own. Okay, now let's find some x and y intercepts. So we've got examples A, B, and C. I'm going to jump to C. Recall, whenever I see an f of x, you can always put y equals. So this is really saying y equals 4x minus 1. So I'm going to start by finding the x-intercept. To find the x-intercept, I'm looking for x, so I plug in 0 for y, and I solve for x. So I would add 1, divide by 4, and I get 1/4 equals x. Now, an x-intercept is a point. Therefore, we want to write that as an ordered pair. So the x-intercept is the ordered pair 1/4, 0. Our y-intercept, we can do the same thing. We can plug in 0, but this time around, we'll plug it in for x. And this would simply give me negative 1. So my ordered pair for the y-intercept is 0, negative 1. Recall with a y-intercept, you don't even have to plug in 0. If my equation is in the form of y equals mx plus b, remember my b is the y-intercept, which is negative 1 right there. So we can just write the ordered pair as 0, negative 1 without having to substitute in to solve. Make sure to try A and B to find those x and y intercepts. Okay, now let's write some linear equations. So it's asking us to write it in both slope-intercept form and standard form. So just remember, slope-intercept form is y equals mx plus b, and standard form is ax plus by equals c. Okay? So we have a line that passes through our x-intercept and our y-intercept. When I have an x-intercept and y-intercept, like I said, I like to refer to those as actual points. So an x-intercept I can write as negative 3, 0, and our y-intercept we can write as 0, 6. If I'm writing in slope-intercept form, I need two things. I need the slope, and I need the y-intercept. The good news for this problem is I have the y-intercept, but I need to find the slope. So to do that, I use my slope formula from the last set of notes. Recall our slope is y2 minus y1 over x2 minus x1. So if I plug that in, we'd have 6 minus 0 over 0 plus 3, because it's minus negative 3. And this would give me 6 over 3, which is 2. So now I know that my slope is 2, and that b value, the y-intercept, we already have, is 6. Therefore, I can pop that right into our equation. So in slope-intercept form, we would have y equals mx plus b. So there is slope-intercept form. However, we're also asked to find standard form. I do not need to start from scratch. What I will do is I will take my equation that is in slope-intercept form and I'll rearrange it. For standard form, I need my x value on the left-hand side. So I'm going to subtract 2x. This now gives me negative 2x plus y equals 6. So now I'm in what I call pseudo-standard form. I have everything in the right locations. ax plus by equals c. However, we need to now check those 3 rules. No fractions, no leading negative, and GCF of 1. The good news is there aren't any fractions. However, there is a leading coefficient of negative 1. So I'm going to take all of this and multiply through by negative 1. This will now become a positive 2x, a negative y, and a negative 6. And there is my standard form. Okay? All right. I'm going to have you try B on your own. Remember, this will be very similar, but we do not have the y-intercept, so you need to go find the y-intercept, okay? So your goal for this one is to first find our slope, then you need to find the y-intercept, and then you can write your equations. Okay, so that was my hint for you for that one. Let's go down and look at B for number 4. Okay, for this one, we are given a point. So we have the point 6, negative 5, and we're given the fact that the line will be perpendicular to this line. So what I have here is a point of 6, negative 5. And then this equation is going to be helpful to tell me the slope. Because if I find the slope of this equation, I know if I'm perpendicular, I'll be the opposite reciprocal slope. So I'm going to take that equation and I'm going to solve for y to get it into y equals mx plus b form. If I subtract 3x, I now have negative 1/5 y equals negative 3x plus 3. Multiply through by negative 5, and I get y equals 15x minus 15. Okay, so what that's telling me is that I have at this point of 6, negative 5, but now my slope is going to be the opposite reciprocal of 15, which means negative 1/15. From there, I can now write my equation, okay? So I know I want y equals mx plus b. We don't have that b value, so I need to find it. I'm going to take a point, negative 5 in for y. I'm going to take that y-intercept, take that slope, plug it in for m, and our x value. Now I will simplify. So we have negative 5 equals negative 6/15 plus b. I can reduce that, so this is negative 5 equals negative 2/5 plus b. I'll now need to add 2/5. So remember, this is really like negative 25/5 equals negative 2/5 plus b. So when I add 2/5, we get negative 23/5 equals b. So in slope-intercept form, we have y equals negative 1/15 x minus 23/5. Okay. From there, we need to write it in standard form. Oh, I apologize. I did not do the directions correctly. It didn't ask for standard form, it asked for point slope form. So back to point slope form. So here's my slope intercept. Now point slope form will be really straightforward. Point slope form is simply then y minus y1 we found was 6. Sorry, it was -5. So that'll be y plus 5 equals m, which is -2/5. I'm sorry, I keep looking at the wrong screen here. Our slope, we said, is -1/15 times x minus x1. And that is our point slope form. Okay. You do A, this one will be very similar, but remember for parallel, we have the same slope. All right, and last but not least, I'm going to have you practice writing in standard form, so just rearranging these equations. I'll do one of them here. So this guy here, to write it in standard form, we need to bring our x over. So now I'll have -1/2 x plus y minus 7 equals 0. We need to have our constant on the right side, so I'll add 7. Now I'm in pseudo-standard form. Everything's in the right location, but I have fractions and a negative. So what I need to do is I need to clear that, and I'll multiply by -2. And that will clear both the negative and the fraction at the same time. So this will give me positive x minus 2y equals -14. Now I'm in official standard form. Okay, determining the x and y intercepts and graphing. So you have two options. Again, we can plug in zeros, or we can actually rearrange the equation into y equals mx plus b. So I'm going to do b for you. If I rearrange this equation into y equals mx plus b, subtract 4x, now divide through by -2, and I get y equals 2x minus 6. That tells me right there that my y-intercept is the ordered pair 0, -6. To find the x-intercept, we need to plug in 0. So you can plug it in from the beginning or from the end. It doesn't matter, okay? I'll plug it in from the beginning. We're plugging in 0 for y because I'm looking for x. This gives me 4x equals 12, so x equals 3. Now, when I ask you to graph this, I'm going to have you practice graphing it using our slope and y-intercept. So we plot our y-intercept first. 1, 2, 3, 4, 5, 6. And then we use our slope. So we go up 2 over 1, up 2 over 1, up 2 over 1. And look at that. If we take a look, our y-intercept, yes, is at 0, -6. And our x-intercept is at 3. Now, use a straight edge. I don't have access to that on the tablet, but use a straight edge to connect those dots, and so you have a nice linear equation. All right, go back and fill in the ones that I have not done and submit those for tomorrow. Have a great day, everybody.